There we go. Okay, so when we do slingshot rockets, it's more about building it. And if you don't have all the materials today, ladies and gentlemen, don't worry. Don't stress. The teachers I know gave you a link to a drive that has all the videos in them. You can search my name and ESU5 on YouTube. All of the videos will be up, including the one that's the stream one and the one that is the one I'm recording. So it's kind of double dipping. So I'm kind of getting the same video twice, but it's better to have them both up there because they look kind of different depending on how you do this, okay? So here we go. So I like to talk about this one because space science is kind of cool and launching things is kind of cool. So remember, if you have these things, a zip tie pipe insulation tube or a cardboard tube or even a toilet paper tube, you know, toilet paper is scarce, but you know, as long as you have that, you're fine. A rubber band is great. The longer the rubber band, a little bit better. The fresher they are, the better they work, because you know you can only stretch a rubber band so much and then duct tape for the things that we need, okay? So when we do slingshot rockets, most of this is actually the building part. So when we talk about space science and how we actually use rockets, we need some way to get things off the ground. And when we use rockets, we have to launch them with a whole lot of power to get it off the Earth. The only way you can get something into space is to break through the pull of gravity. Okay, gravity is very strong. Gravity is very tough, and you have to be going, in order to get out of the pull of gravity of the Earth, you have to be going at a pretty ridiculous speed. I don't know off the top of my head what it is, but it's a pretty big number, okay? So something cool about rockets, though, is the more that we've gone forward, because we don't have as much of NASA sending up manned flights as much as what we used to, but a lot of them are unmanned nowadays to put satellites into orbit, because we use satellites for a lot of things, like our cell phones, okay? But the neat thing about this is when we talk about motion, for every action, there's an equal and opposite reaction. So if I push the wall, okay, if I push against the wall, I'm going to rebound backwards. If I drop a bouncy ball on the floor, it's going to come back up, right? For every action, there's an equal and opposite reaction. If I punch the wall, my fist will come back and I'll yell, ow, that really hurt, okay? Any of those things are things I can do. If I pull my thumb back, it rebounds. Action, reaction when I let go, okay? My action is pulling my thumb back. The reaction is my thumb muscles are stretching, okay? If I let go, my thumb springs forward. That's an action and a reaction, okay? I can fold my ears down because the cartilage is stretchy and elastic. When I let go, boink, they flop back up, okay? Action and reaction, really simple. I've got a sleeping cat on my bed. If I threw something at it, it probably would wake up, okay? It'd be silly. Anyway, when we use rockets, we really focus on the action and reaction. And what's really cool is I want you to watch, they launch this into space, and this is the Falcon Heavy, and I want you to kind of watch, I might skip ahead a little bit. They've got two separate booster rockets, and usually they let them fall into space. Oh, this is a long bit of time. Okay. So you got these two rockets. Now watch what they do. Okay, this is really cool. They're coming down back from putting something in space. And what they decided to do, instead of letting them parachute, they put reverse thrusting rockets on them. And their goal was to land them back on the Earth. Now notice they're pushing, it's falling down. They're pushing their booster rockets up to slow them down. Watch what happens here. Landing pad down, 3, 2, 1, and they touch down at the same exact time. Okay, let's watch. See, it's falling, falling, falling. Instead of letting it fall, it pushes it's falling down towards the Earth. It pushes its thrusters back up to slow it down, like hitting brakes on your car. Then it folds out its landing gear as it aims for the target. And their goal on the Falcon Heavy was to land the booster rockets back on the original launch pad nicely. Check this out. I love showing this. It's cool. See, here it goes. Landing pad down, landers down 3. Look at that, slows it down perfectly. Mwah, beautiful. That, my friends, is awesome. Look, nothing hurt, no problems. Landed the rockets perfectly after launching them up into the boosters up into space. That, my friends, is by far the coolest thing I think I've seen. One of the coolest things. I've seen cool stuff. That is by far one of my favorites. Okay? So when we look at why these rockets do what they do, it's all about Newton's laws of motion. For most of your life, unless you're an astrophysicist, dealing with motions of planets and stars and things that are way out there doing ridiculous amounts of math, these will govern your life. Don't stress. Because in Newton's laws of motion, they tell us what we do. First one is Newton's third law of motion that we know pretty well. For every action, there's an equal and opposite reaction. So every time I hit my fist comes to a stop. I hear the sound, and my fist gets pushed back a little bit. That's how it works. Okay, easy. If I throw a ball up, gravity pulls it back down. Not hard. You all know that. Really, really simple stuff. The first law of motion is one that you know also. It's a little bit more painful because it tells us that objects in motion want to stay at motion and objects at rest want to stay at rest. It's why you don't want to annoy your dogs or cats while they're sleeping. They're an object at rest. They want to stay at rest. If you didn't want to wake up this morning and somebody had to wake you up, you're an object at rest that wanted to stay at rest. If you go outside today and you're running around, well, you probably want to stay outside and keep running around. You don't want to be in here doing all of your lessons all the time or having to finish up your homework. It kind of annoys you a little bit, right? Because you're not in motion. You're not doing the things you want to do, okay? You're resisting change. That's just kind of how it goes. That's just how it goes, right? We all do things we don't want to do, right? I didn't really want to wake up this morning. I wanted to fall back asleep for a little bit, but I couldn't. So I just got up, all right? If I'm my cat who's over here, let's see if I can get a good picture of that cat over there. All right, hang on a second. Here we go. Just switch my video. It might be upside down. Let's see what happens. There you go. Perfect. All right. See the cat on the bed over there, guys? The gray flump of fur, okay? You can obviously see that that object right there is an object at rest, and it wants to stay at rest until something causes it to wake up. Like me, all right? Or something might wake it up, okay? Or I decide to poke it, or whatever. Not a good idea. But anyway, objects at rest want to stay at rest. The last law of motion is one that if I say it, it's hard to understand. But if I explain it, it's a little bit easier to understand, if that makes sense. It's actually one that we use a lot in sports. Because the more mass something has, the heavier it is, the more force or effort or work it takes to make the object move. Okay? So if I pick up a tiny pebble, it's pretty light. If I try to pick up a 2-ton boulder, I can't do it on my own. Okay? The heavier something is, the more mass, the more stuff it's made of, the harder it is to get it to move. Also, on the opposite side of that, once that heavy object starts moving, it's really hard to stop it. Okay? Think about a train or a fully loaded semi. Once they get going, it's hard to stop them. Okay? They have a lot of what's called inertia, resistance to change, a lot of mass, a lot of stuff that keeps it moving. If you think about a rocket, those things are heavy. And if you think about those boosters, remember when I went back up to these boosters that I was showing here and here? Think about how big these were, okay? Look at the size of them. They're pretty good sized. Okay? They have a lot of that liquid oxygen, rocket fuel in there that can be used to push a very heavy object into space. Okay, you guys are younger, you guys wouldn't know the space shuttle. That was what was around when I grew up. If you've ever seen that thing live, it's ginormous. Okay, the fuel tanks, if you've ever been to the SAC Museum in Ashland, I would suggest going. Some of the rockets in there, the Atlas V that's out there, or the similar one that's close to the Atlas V, is actually about the size of a rocket that they used to put some of the early space capsules into orbit of the Earth and towards the moon. It's ridiculous. They are huge. We're talking 5, 6, 7 stories tall. Just ginormous. Okay? And so it's really, really cool to see, but it takes a lot of effort to move heavy things. Okay? You can push a feather easy, can't push a 2-ton boulder easy. All right? So I'm going to pause here real quick. If you have questions, if you have any questions, why don't you ask them now, okay, before I start building. Don't worry about the stuff. If you have questions about motion, now's a good time to ask those questions if you have it. I'll keep an eye who's here. I'll take a look. If you don't have questions, that's fine too. Oh, somebody showed up. Somebody rolled out of bed. All right. Doesn't look like there's any questions. I must have done a really good job of explaining it. Yes. All right, let's go to the building part. Okay, so I'm going to show you how to build this real quick. I'm going to do my best to explain it as best as I can to you and show you how to build this. Okay. Make sure you're muted, please, if you're there. I think you still have the option to unmute yourself. If you would mute yourself, that would be really helpful. Oh, I can stop my share there. Okay. Make sure everybody's muted real quick. I'm going to unclick that. Sorry, guys. It's not that I don't want you to. I don't want you to like talk to me or ask questions. It's just I want you to make sure that we don't get feedback. Okay. So here is where we start. Okay. I'm going to check to make sure that's good. Okay. Perfect. That's live there. Great. Okay, so what you'll need are the following things. You're going to need a pipe insulation tube. Okay, I've already done a little bit of work with this. I had cut this in half earlier. Okay, if you have this pipe insulation tube, this will work great. I cut it into about a 6-inch piece. Okay, I taped the edges. Yours will be solid. Mine, because it had been pulled apart already for something else, I taped it back together. That you can make it shorter. You can make a short little rocket. You can make a longer rocket, doesn't matter. If you have a paper towel tube or toilet paper tube, go ahead and use that. I'll use this one here. I'm going to cut a little bit of this one off just because I'm going to show you how to do this a couple different ways. All right. Show you how to do a couple things, okay? So I've got a tube here. I've got this. This will work just fine. These aren't really any different. It's just this is squishier and easier to work with, okay? You'll need a zip tie, and you'll need a zip tie that's long enough to go all the way around, okay? If you have to use 2, that's okay. You could use duct tape to put the rubber band on. That's fine. There are so many different ways to do this. It's easy, okay? And yes, you'll need duct tape, okay? I have this Gorilla Tape that I just happen to have. Gorilla Tape is hard to work with. It's very thick. It doesn't tear very easy. If you have good duct tape, use it. You don't want too much because once you add too much duct tape to this, you add more mass, which makes it fairly heavy, okay? I'm going to try to go slow and steady so you guys can kind of watch what we're doing. I put a little bit of tape on the top to cover this just to seal it. You don't have to do that. I was making a little nose cone. You could make a nose cone out of it. It's not a big deal, okay? Most of the time when we see the rubber band or slingshot rockets, you see them in this form, okay? They have a hook on there. We're gonna build our own hook. You can build a nose cone, and notice it has 2 wings. These are set so they can helicopter back down. These won't helicopter back down because we're gonna try to launch it like an actual like football or rocket. Something like you're launching something, okay? So, first step, I'm gonna show you how to do this with a zip tie. The second one, I will show you how to do, I'm gonna wing it. First time I've done it, we're going to see if we can figure out how to do it with just a rubber band and some tape. Does that sound okay? Sound good? Sounds great to me. It's a good thing I'm thinking. We'll give it a shot, all right? So, what you would do is if you have a zip tie is this, okay? You're gonna put the rubber band on your zip tie, okay? You're going to put your zip tie all the way around towards the top. Just watch, okay? And then you're going to lock the zip tie in place. Don't pinch it down too hard because you don't want to squeeze your tube. And there you go. You now have it done. You can cut the little tail off. And guess what? That's all you really have to do for the zip tie. Congratulations. Is that pretty easy? That's pretty easy. That's if you have a zip tie. We could probably do the same thing, and I'm going to do this here real quick. I wish I had, do I have a rubber band nearby? I'm trying to look to see if I have a rubber band. I don't want to steal that. That's okay. All right, we're fine. I'll just steal it off of here. Right? Right. We're just going to do some science. Okay, so I cut that off. You can always redo it. Zip ties are fairly cheap as long as you can get a hold of them. So I'm going to leave that there. Put that off to the side. Let's see if we can do this with some tape. Now, how much tape am I going to need? I'm going to estimate how much tape I'm going to need. I'll leave that there. I don't want it to stick all the way. Keep some here. Here is what I would do. What I would do in order to make this work is I would do the same thing. Put my rubber band underneath some of the duct tape, tape it down, okay, and then bring the other side of the duct tape over the top and just clamp it down. Oh, that actually works pretty good. Hey, look, that works pretty good, doesn't it? That'll work. Hey, look at that, we did it. All right, we scienced. All right. What they usually do on these helicopter ones is they pull them into a point, and then they usually kind of hook them. Where's your hook point on this? Usually they'll put a rubber band here and it'll launch from here, but I don't know where you're. Hey, buddy, where's your hook point for this? You have no idea. Awesome. Great. That's awesome. So that's what I would do there. There's easy step. Notice this is a much thicker and longer rubber band, maximum stretchiness. Okay. This one's a pretty thick one. Gives us pretty good stretch. Now, this isn't going to be perfect. I'll tell you that much. All right. Next step. Okay, go ahead. I see some of you are working. Go ahead and stop real quick. Okay, stop with me real quick. Next step is you need to build some fins, some wings. You want to aim for balance. All right. 2 over here will work okay, but it'll fly kind of like an airplane and it'll spin a lot. The best thing you can do is to build 3 fins that go 1, here's how I would do it. 1, 2, 3 fins. Okay? Or 4. 1, 2, 3, 4. Those balance the best. The nice thing to do, here's one way to think about this. I'm going to build some small fins for you, some ideas. Here's what I would do. A couple ideas. Okay, so go ahead and stop real quick with me. A couple ways to build some fins. Watch what I'm going to do. Okay, one way is to take a piece of tape, flex it, stick it together. Okay, see I kind of stuck it together, but don't stick it all the way. And then set it on top of your fin just like this. And that works pretty well to make a fin. Another way you could do this would be to take two separate pieces. Let's make a longer fin here. Should I cut triangles? Yeah, I'm going to cut triangles. Okay, so I'm going to take mine. I'm going to cut some triangles. And that's not working very well because my tape is being stubborn. And what I'm going to do is I'm going to do the same idea. Watch real quick. Watch. Here we go. Uh-oh, I got a problem. These don't match up. Oh no. Okay. I got a sticky side on one side and not sticky on the other. Way to go, Patrick. Here, here, and here. I'm going to kind of match these up like I did here. Then one side like this, and then stick it down and match the other side with it. I don't know if I can. I think they're a little small. And the other side, and stick it somehow. So that works. That's another way to make it work. Now, is it going to fly very well? Probably not. Can you build and test all that you want, ladies and gentlemen? Absolutely. Feel free to build and test and do everything you'd like to. I'm going to leave this like that. And I'm going to put one here. I'm going to put one there. I'm going to put one right here. And then, let's see how well we'll check this. Then all you need to do to launch this, sorry if you're a little dizzy there. Okay, to launch, hold it in one hand, pull back with the other, and, oh, that didn't work. I got to think about how to do this here, see if I'm smart enough. I'd be smarter than a rocket. You don't want to do it this way, because if you do it this way, what's going to happen? You're going to launch it in your face. That didn't work. It should. We'll see if I can do it. Oh, I launched it backwards. Whoops, launched it backwards. That didn't work. Yeah, that's going to go backwards. I want to go this way. So you got to kind of play with it until you figure it out, because obviously I'm not smart. So usually if you pull it, there we go. All right, I got it. E, can you grab that for me? Oh. My help is not helping. My help is not being helpful. So here we go. We'll try it again. Here. 3, 2, 1. Oh, it was terrible. All right, perfect. It worked terribly, which is great. Because if it doesn't work, keep trying. Because there's no right way to do this. There's no wrong way to do this. All you need to do is keep building and testing it. It'll work. If you have the insulation tube, that's the nice thing. It doesn't flex very much. And if you can zip tie it, it holds it in place really nice. Give it your best shot. You have nothing to worry about. It's cheap, it's easy, and if it fails miserably, tear it apart, take the rubber band off of it, toss that example, and try it again. Build, rebuild, and test. That's how you learn how to do this well, okay? So I'm going to go ahead and stop all of my